Okay. Okay, so basically the question that Damien asked that I go over is he was saying that he's written down the definition: a skeptical position or claim to be tested is what he's got for the null hypothesis. And then so he's wondering kind of what is the alternate hypothesis? Is it the opposite of the null? Again, I'm reading some posts that are coming in and I'm getting mixed signals. So he's kind of wanting to know how do I determine what is the null and what is the alternate? Okay.
Yeah,
So,
I think I might have confused him.
well, it's okay. It's all right. No big. We will fix that. That's what I get paid the big money for here, right? Let's go ahead and change my little palette here so I can have some colors if I want them. All right. So the basic idea behind determining the null and the alternate hypotheses is to, first of all, it seems almost backwards, but it's really the best way of doing it, is to identify the alternate first. So we want to know the null, and we want to know the alternate, H1 and HO. And the reason for that, why you usually go for the alternate first, is because the alternate hypothesis is going to be the researcher's hypotheses. So in other words, it's many times just referred to as the research hypothesis. So with that in mind, if we come back up here and take a look at our little problem statement, a researcher questions the average body temperature being 98.5 degrees Fahrenheit. She believes it's less than that. State the null and the alternate hypotheses. So notice that she is the researcher. So her hypothesis is that the average body temperature is less than what the null claims. If you look at every thermometer, at least manufactured in the United States, because we're on this crazy Fahrenheit system, they're going to tell you that average body temperature is 98.5 degrees Fahrenheit. Well, she thinks it's less than that. So what she would state is that the null hypothesis is that the mean, or the population average body temperature, is less than 98.5 degrees Fahrenheit. And then the null, where Damien's saying, well, it's the opposite of that. It's the null always is going to contain the conditions of equalities. It's always going to have an equals in it. And the reason for that is the null is not being wishy-washy. It's saying this is what the parameter is. The null is saying mu is 98.5 degrees Fahrenheit.
Okay, one thing that I've been wondering since we first encountered the null hypothesis a couple chapters ago, say you have an accepted hypothesis, a commonly accepted hypothesis that isn't necessarily negative, like eating fat makes you fat. It's or at least it used to be a commonly accepted hypothesis, but it's not necessarily negative. And yet I keep hearing all of these sources online and in the textbook saying that the null tends to be negative or is negative.
I mean, negative like in terms of not being a good thing? Or
negative as in there's no relationship between these two variables.
Okay. Right. Okay. So that is a negative in that there is no relationship. So so we're negating that idea. So in the case of what you're saying is eat fat, get fat, right?
Yeah.
So eating fat is equal to getting fat, right?
Yeah.
And so the alternate would say what?
It would say
eat fat.
Maybe inconclusive evidence?
How about not get fat?
Okay.
Okay. All All right, now that's a really good first whack at it, okay? So this would be like a preliminary statement of what you want your null and alternate to be. The reality of it is, though, is that we have to get these both into some sort of a measurement of a parameter or some sort of a statement based upon a population parameter for us actually to conduct a statistical hypothesis test.
Right.
Because we have to be able to collect data that does something about eat fat, get fat, right? And then we need to see whether or not there really is a relationship between the two of them or not.
Now, I guess my thought was, like, I wasn't necessarily thinking of the numbers. I was thinking more of the concept.
Mm-hmm.
Like,
that's an excellent first start. That's what I was saying. That's definitely where you want to start.
Because I mean, I keep hearing all of these sources, including the textbook, saying that that the null hypothesis states there is no relationship. And I guess I've been really confused about that, because here I keep hearing all of these accepted hypotheses that state there is a relationship between these two variables.
Mm-hmm.
And maybe they're qualitative, maybe they're quantitative, but
well, let's go quantitative
okay.
to start, because quantitative will be we really have to process for determining what the null and the alternate is and how we do the testing changes based upon the variable type. So let's start with quantitative or numerical to begin with, okay, just to make it easy. So let's say that the status quo right now, I mean, let's take your eating example, okay? So the status quo could be that the dietary recommendation for fat consumption put out by the FDA will, based upon that particular person, because, you got to remember what they're doing is they're saying at a particular body weight, right? In a particular calorie level diet, that by eating that amount of fat that you're basically going to stay healthy. Okay, so get fat would be would not be healthy. Okay, does that make any sense, Catherine? I mean, I got to come up with something that gives me some sort of numbers to play with. So
yeah, that does make sense.
Okay, so say the FDA. Let's just go with an example here. So say the FDA says eat no more than, I don't know, let's say, let's do it in calories, because I don't know, the units are, since I'm making this up off the top of my head. So eat no more than 350 calories of fat in your diet per day. Okay, so let's just say that's what the FDA says, all right? So if that's, and it supposedly if you do that, right, if you don't eat any more than 350 calories of fat per day, then the inference here is what? That this is going to be connected with that you'll stay healthy, right?
Right.
Okay, and there's going to be lots and lots of ways that we can measure stay healthy. But let's say that one way of measuring staying healthy is cholesterol level.
Is there any way to move my... Hey, I can move that.
Yeah, all the windows are floating. You can move things around and reshape them or resize them.
Okay.
And there should be a little square up in the upper right corner that lets you make it full screen or shrink it down into a small.
Oh, yeah. Yeah. I remembered that. I just couldn't see what you were doing.
Yeah, well, that doesn't good. Why are you here if you can't see it, right? Don't make no sense. All right, anyway, so that's basically, so stay healthy is cholesterol. Let's say that's the measurement we're going with. and cholesterol less than 200 is considered to be, you're in the healthy zone, okay?
Cool.
You with me so far? Okay. So that's the null hypothesis. So that's the status quo, right? And what the researcher would say, and you know, and maybe it's a little misleading in the first shot at saying no relationship versus a relationship, because it's really not that simple. I mean, they're trying to make it as digestible as they can in the first pass, but it's perhaps a little more general than that, a little more open. You don't have to be stuck and rigid to what they were talking about there. So the FDA, no more than 350 calories will keep your cholesterol less than 200. Let's say that's what the null hypothesis is saying. And the researcher is saying, so you got somebody who doesn't believe that that's true and believes that the calories per day is too high, right? And so it's incumbent upon the researcher. So you can think about it, and we're gonna come to this analogy very soon in the class. We can think about this as that actually that HO is on trial. HO is the defendant. HO is the person who's being brought to court saying, we think that you're the perp, all right? You're the problem here, right? The H1, that's the prosecutor. That's the person that has to show that the null is incorrect, that the null is not innocent. In fact, they're guilty, okay? And so by taking that standpoint, it's incumbent upon the alternate, or the researcher in this case, to provide evidence that would be so unbelievable to be seen under the assumption that the null hypothesis was true. Is that making any sense at all?
Yeah.
Okay. So what the alternate would say is that, okay, I don't think this 350 calories of fat per day, I don't think that leads to, in other words, the null saying that leads to health, okay? And the alternate over here is saying, nah, I don't think that's true. That's not true. That's not going to be healthy. And since it's not going to be healthy, I think that the cholesterol, and there's supposed to be an H in there if I remember correctly now, it's supposed to be CHO, that the cholesterol is not going to be less than 200, but in fact it's going to be greater than 200. In other words, there is a relationship, a problem with it. So now that's the first stab at it. Now it gets more complicated, because now you got to have to come up with some sort of a way of designing an experiment or an observational study in which you're going to go back and take a look at the calories of fat per day that the person looked at and their corresponding cholesterol, and look at the relationship between the two of them and see whether or not they're at this calorie level, are you going to keep cholesterol less than 200? And so the alternate's job is to show that they're going to find a disproportionate amount of people with cholesterol, say higher than 200, that are eating 350 calories of fat per day. And so to the point where that seeing that many people with a higher cholesterol than 200 would be so improbable, given that the null was true, that we're going to say, I'm not going to accept the null. I'm not going to take that. In fact, I'm going to reject it. I don't believe the null is true based upon the evidence that I'm seeing. So that's a fairly complicated example. Let's do something a little bit simpler, maybe. Okay.
Okay.
Let's do one that maybe that's a little simpler to see.
I tried to go simple.
That's okay. That's all right. But it's a good question. It's maybe a little more complicated than we want to get at this point in the game. Okay. So let's do. We'll look at a relationship between two variables again, because I think that's kind of where you're at the moment. We're going to look at where our first variable is going to be a status quo, a known variable to start with, and that's going to make things a lot easier. It's a single parameter that we're testing, and not more than one parameter. But having two parameters is actually more common in the real world than having a single parameter. So we'll roll with what your idea was, okay? Because that's kind of what you're saying. You have two things and you want to see whether there's a relationship with them or not. So a real common one that we start off with, and one of the more easy ones to look at, is the idea of before and after data. And so you have a single subject that has a parameter that we're going to measure on them before, And they're going to apply some sort of a treatment to them. We're going to do something to them. And then we're going to have an after. Can you see that okay, or am I off screen?
You're okay. I just thought of a question.
Okay, go.
Let's see if I can remember it. So you just mentioned 2 parameters, and it kind of brought to mind what was it, the two-tailed test.
Okay, I'll tell you what, hang on to that. I'll use that in this, okay?
Okay.
Yeah, because that's a separate idea, but it's important to hypothesis testing, okay? So let's look at before. So let's say, let's stick with cholesterol again, okay? We'll do that. So the before cholesterol, and then let's say we put them on a low-fat diet, okay? So we do a low-fat diet, no exercise, nothing, just a low-fat diet. So you don't get any cheese, you don't get any ice cream. I mean, life sucks, all right? Okay, and then we're going to take a look at their after cholesterol. So making sense so far?
Yeah.
Okay, now you're going to do this. You're going to have each individual is going to have 2 measurements on them. They're going to have their before measurement, and they're going to have an after measurement. Right?
Right.
Okay. And so you're going to have to do a fair number of people. Let's say at least 30 here that you're going to do this with, that you get into your study. So you're going to have their before cholesterol, there is going to be some sort of an average for that population. And so we're going to say that maybe that population's before cholesterol, their population average is mu. And we'll call that mu1. So that's the population mean for cholesterol for all the people before we start saying no more ice cream, no more butter, no more life, no more bacon for you.
Another question.
Mm-hmm.
Would that be the population mean, or would that be the sample mean?
Okay, so I think I sent you guys out a little handout that I told you that was really important.
Yeah.
You remember that one? Maybe.
Yeah.
Possibly. Okay, so it was the mean, and then we got the stat, and we got the parameter, right? There's an A in there, param, okay? And so it was a little table like this. And for the mean, the stat is X bar. That's from the sample. And then the parameter was mu. So one of the nice things about parameter and statistic is stat comes from a sample, right? Parameter comes from a population. So the first letters line up, which is really kind, okay? So
I
it's
remember
a sample statistic and a population parameter, okay?
I remember this.
Cool. That's good. All right, so back at the ranch here, hypothesis tests are about populations. They're not about samples. We use samples to determine the relationship, okay? But the statements for the null and the alternate are all about some sort of measurement on a population, not some sort of a measurement on a sample. So the null hypothesis here would be that, I don't think so, buddy. I'm not giving up ice cream. I'm not giving up bacon, thank you very much, because it's not going to make a difference. There's no difference between my before cholesterol and my after cholesterol just because of your stinking low-fat diet, okay? They're going to be the same as each other. So that's what the null hypothesis is saying. So in terms of what you were saying earlier, there is no relationship between the variables. The low-fat diet doesn't change anything. It's not causing a relationship between the two. Is that helping at all?
You want to repeat that?
Okay. So what's going on is that these two variables being equal to each other means that the treatment, right, is not in any way effective. There's no difference between the first one and the second one. The non-fat diet is not changing the population mean cholesterol level.
Okay. And so that's supposed to be for the alternate?
No, that's the null. The null, one thing to keep in mind is the null is never wishy-washy. It's always going to be the statement of equalities. That's always going to be an equals between your parameters and the null. Because what that really says, by saying that they're equal, it's saying that the treatment made no difference. In this particular example, like I said, there's going to be lots and lots of different statements for the null and alternate, and lots of different things that we're testing. But in our particular example, what it's saying is that the treatment, the low-fat diet, made no difference. There's, you know, you might as well have had them drink, you know, cod liver oil. It would have made the same amount of difference. There's no difference between them. Versus what was the alternate going to say? Well, what's the researcher think? Well, the researcher thinks that the before cholesterol is going to be bigger than the after cholesterol, right? The reason you would do this is you'd say, because it's going to drop my cholesterol, right? Because I'm not eating as much fat. Yes, no, maybe? Catherine, you're looking confused.
Yeah, because I thought...
The null says no difference. There's no relationship, there's no difference. The alternate says there is a relationship, there is a difference. That the two parameters are different from each other.
Okay.
And so now, once you set this up, right? Once you set this up, the job of the alternate is to come in and produce evidence that would get us to say we reject the null hypotheses. In the analogy that I was using in a court case, you can think about it this way. So if the null is the defendant, if HO is the defendant here, right? So if HO is the defendant, then, and the alternate is the prosecutor, then what we know is, if you think about it in the American judicial system, that we're assuming the null is correct unless you can produce evidence to tell me otherwise, right? So what that says is that, I mean, take these ideas right here and let's transfer them down to what the statements go for the court case. Is the null is that it's innocence, right? And what's the alternate say?
Guilty.
Guilty, right? But in America, you're assumed to be guilty until proven otherwise, right? It's incumbent upon the alternate to produce evidence to tell us to reject innocence and take in its place guilt.
I thought we were supposed to be innocent until proven guilty.
You are.
Didn't you just say the opposite?
No. Let me say it again. You're innocent, okay? That's the assumption. Yeah. The assumption is that you're innocent. And so you're innocent unless the alternate hypothesis can produce evidence to the point where it can reject your innocence.
Right.
And so it would reject your innocence and replace it with guilt if they can do that.
Right.
Okay? If I did say it wrong, I apologize. I know sometimes, you know, it's late and it's Thursday. This is my Friday. I'm tired. It's been a long week. Okay?
Okay.
All right. So can you give me one from the book maybe? Do you have one in particular you can think of from the book where they asked you about the null and the alternate? Or do you want to talk a little bit about the discussion question?
We can talk about the discussion question.
Okay, so let me go get that so it's front and center. I'm not going to, you know, obviously I can't give it to you yet, but I can totally give you hints and push you in the right direction. How about that? We can discuss it. How about that? We will discuss the discussion question.
That sounds excellent.
Perfect. All right, so let's go get into the module here. And scroll down. Let's see. We're in module 7, discussion question 1. We have 2 questions for this week, by the way. Okay, so this is the one where we're looking at, well, it's not for this week because it's a 2-week assignment. So there's actually one next week is how it is. But 2 for this module, I should say, because we're going to spending 2 weeks on this module. Okay, so the article from the BBC was, if we go take a look at that, let's go to the actual BBC site here. It says divorcees have more heart attacks, okay? And so divorcees are more likely to have a heart attack than their peers who stay married, US researchers suggest, okay? All right, so let's think about that for a minute. So there are, we'll make it easy. The parameter here, probably the simplest way to think about it is in terms of proportion of a population that has a heart attack in the United States. So is that, you with me?
Yeah, I think so.
Okay, cool. All right. So it's going to be a slightly different parameter. We're not going to be talking about mu. We're going to be talking about p for population parameter. But we really don't need to do it symbolically. We can do it in English, and that's okay. All right?
Yay!
Well, we got to get good at doing it symbolically too. That's going to be important, but it's perfectly fine to do it in English here, okay? So there's the null, and then there's the alternate. Okay, so let's go back to the article here for just a moment. So, research. Whose argument is this right here? Tell me whose argument that is. Is that the null or the alternates? Keyword.
Research. So that would be the alternate?
Oh, you are good. Yeah. You got it, right? Why? Because the research hypothesis is always going to be the alternate. The researcher is the prosecutor. The researcher is the one who's got to provide evidence to say that the null is not true, right? Yes?
I was confused.
Is it making more sense, though?
Yeah, I think so.
All right. Well,
okay. So when I first looked at the discussion question, I was thinking that was the null hypothesis. And then I thought, but wait, no. And then I scrolled down a little bit further and started wondering about the causes. And then I think that's why Damien got really confused.
Okay. Well, that's okay. This is something that takes a bit to get your head wrapped around, but it's really important. Is why we got to talk about it as much as we can, so that when you read somebody else's work, you're able to identify from the work what the research hypothesis was and what the null hypothesis was. Okay, so let's go back for a minute to the article. I mean, we got it right there in the opening, right? That we're going to go here. That divorcees are more likely to have heart attack than their peers who stay married, okay? So the population of interest here is divorcees.
Yes.
In particular, they said it seemed to be in women. So we already know that death of a close one can greatly increase it. Now Duke University showed that a similar effect after divorcee. And so they said the women divorcees were 25% more likely to have a heart attack in the study than women who were continuously married. The figure was 77% for those with multiple divorces. By men, there was only a modest extra increase in risk with divorcees and 30% after multiple divorces. So it seems that it was actually, even by gender, it was even a bigger effect with respect to women, okay? But we can go totally general here and not split it up by gender. We can just stay with independent of that. All right. So if we think about that, let's come off to the side over here first. And what we're going to say is that the population of interest is divorcees. Divorcees reminds me of a Neil Young song. Okay. And what we're measuring on there is the rate of heart attacks. Myocardial infarctions, okay? All right, so now you have to decide how you want to measure that rate of heart attacks. It's usually done as a percentage. So that rate of heart attacks, we're going to say that's the percent, okay? That this right here, that's the percent of heart attacks. You good with that, Catherine? That's okay?
Yeah, I was just writing down what you said about the alternative hypothesis is always the one that talks about the research.
Exactly. That's key. That makes it so much easier to pluck it out of an article, okay?
I want to put that in my reference book.
I would, yeah. I'll put that in there, a little sticky note, no alternates research hypothesis. If you get that straight, it's going to make it so much easier. Just always think about that the researcher's hypothesis is the alternate hypothesis. And so what that means is about 99% of the time, the hypothesis that is presented in the article is the researcher's hypothesis, therefore it is the alternate hypothesis. Because when you read an article, it's not the status quo. They don't want to tell you things are the same. Nothing's changed. Oh, we've got a new discovery, right? And so the headline, the tagline is going to be the alternate. It's going to be the alternate hypothesis.
Yeah, that makes sense.
Okay, and like I said, if you think it in terms of the judicial system, that is a really good analogy. It fits so closely. It's actually, when we start doing this for real, when we start working with live data, we're gonna use that analogy pretty heavily to help us write the null and the alternate, and to think about how we're gonna make our decisions. Okay, so percent of heart attack is the parameter of interest, okay, and it's the parameter of interest on the population of divorcees. So percent of heart attack is parameter of interest. So that's the parameter that we're measuring, okay? So let's just call that percent of HA, okay? So the null hypothesis is that the percent of HA, would equal, and then there's going to be some number. I don't know that number off the cuff, but what that number is going to be is that number will be the number for the population as a whole, not just divorcees. Because remember, the treatment here, or the thing that we're looking at that's making the difference, is the divorce. That's right. What we're taking a portion of the population and we're treating them with divorce, and then taking a look at their heart attack rates. Okay, so we're going to say that percentage of heart attacks for divorcees, that's equal to the same as it is for the general population. Excuse my sloppy writing, but is it making sense what I'm writing down?
Yeah.
Okay, so that's something we could go look it up. We could go see what that number is. There's going to be, you know, the NHA, lots of different places are going to have stats on those numbers, and they're going to give you the population values, what they say the current population value for heart attack rates are in the United States. And so what you're saying is, it doesn't matter whether you got divorced or not. The heart attack rate's the same. It's not going to change it.
Right.
But what is the researcher saying?
That heart attack rates increase.
Oh, you're good, right?
In people who are
divorced, right?
Get divorced, especially people who get divorced
multiple times. Yeah, it really goes up if you've got multiple divorces, right? And so that number is greater than it is for the general population. Better, worse, somewhere in between?
So it increases for the more you get divorced.
Yes. But the number that they're comparing it to, the number you're going to have over here, that's going to be the number from the general population. That's going to be a number that's known.
Yes.
Okay?
Okay.
All right, cool. Okay, I want to go do the judicial thing for just a moment, and then we'll come back to this, all right? Because we're going to switch modes here for a minute. Because the other thing that Damien asked me about, he was confused about type 1 and type 2 error. And he wanted to know.
Oh, good.
You wanted to know about that. So Yeah, I figured that would be a good one to talk about too, right? Okay, so let's start off with the general definitions. Then we're going to take a look at it in the judicial system. Then we're going to bring it back to the divorcee and the heart attack, okay?
Cool.
All right, so let's start off with just what the definitions are. So there are two types of error that can occur. One of them is called type 1 error.
Yes.
And then the other one is called type 2 error. Okay, so what are they? Well, type 1 error and type 2 error are mistakes. So these are, as said, they're an error, they're a mistake. And so type 1 error is that we rejected the null hypothesis when in fact it was true. So we rejected HO when it was true. So in other words, the null hypothesis was true, but because of the luck of the draw, there's variability in the data. We got a bad draw on the data, and we came up with evidence that convinced us to reject the null hypothesis, even though in fact it actually was true. And what we want to do is we want to minimize the probability of making that mistake, but that mistake still can happen, even if we minimize it. Okay. Right. So we want to make the probability of that mistake happening as small as possible. We'll talk about that, what that is in a minute. But what that error is that we rejected the null hypothesis when it was true. Okay, a type 2 error is that we failed to reject the null when it was false.
So would that be the same as saying rejecting a false alternative hypothesis?
The null, the type 1 error?
The type 2?
Well, actually, there's an easier way of doing it. I hate this double negation, but there's kind of a rationale behind it. We'll talk about it a little more when we do the chord analogy, but this is a very convoluted sentence. If you took this to your English teacher, they would go, "What are you doing with all those double negations? That's just caca." Okay? So an easier way to think about it, and it's analogous to what I just wrote with the underline up here, is that we rejected the alternate when in fact it was true. So it's the same style mistake. It's just you're rejecting the other hypotheses when in fact it was true. Because here, you failed to reject the alternate when it was false. So, the null when it was false. And if the null was false, then the alternate must have been true. It's a dichotomous situation. It's, one or the other, right?
Yeah.
Okay. So if the null is false, the alternate must have been true. And if you failed to reject the null, then that must have been that you rejected the alternate, didn't you?
Now, in the book, I recall that it said something about just because you reject one hypothesis does not mean that you necessarily accept the other one.
When you reject the alternate, that doesn't mean you accepted the null, or if you rejected the null, it doesn't mean you accepted the alternate. It's just that's where the language comes from. Failing to reject, right, doesn't say that you agree with the other hypotheses. It just says that you failed to reject it. And that's comes back to the court analogy. When you fail to convict the perp, right, if you failed to reject it, in other words, you failed to persuade the jury that the person was guilty, right? And instead, they went with innocence. Well, from the researcher standpoint, that's not saying you're accepting the innocence. It's just saying you did not produce evidence worthy enough to reject the hypothesis of innocence.
Right.
Okay, and so that's kind of where the language comes from. And viewed from that lens, the language makes sense. But in terms of practical use and understanding what it's saying, it's a little convoluted. It makes it difficult at first to kind of get your head wrapped around it as to what actually is going on. So to begin with, a good way to think about it is this way, but you're correct, and you really do, in the long term, you have to think about it from the court analogy. There's a reason we say failed to reject. It's because you're not saying that you're accepting the null. You're not saying you accept the alternate. You're just saying that you rejected one, and then here's the viability of the other one based upon the evidence.
Yeah.
And, you know, then a bunch of other work comes about to actually show what is what. But, you know, let's get to that. We're getting a little ahead of ourselves, okay? All right, so that's the type 1 error is reject the null when it's true. The type 2 error is fail to reject the null when it was false. So in terms of a court case, if we come back to it again, if we go H1 and HO here again, and we say, okay, HO, that's innocence, and HA or H1 is guilt, okay? So what would a type 1 error be in that case? Well, it's rejecting the null when it was true. So a type 1 error would be that we rejected innocence, right?
So it would be like a false conviction.
Yeah, exactly. Good job. You reject innocence when in fact it was true.
I want to write that down. True.
And so, yeah, you basically convicted somebody who was innocent. Now, of course, what you want to have happen is you want to make the probability of that occurring really small. You want to make the chances of that error occurring as small as you possibly can. In terms of the judicial system, that means, you know, the checks and balances that are within the system and the court system are supposed to minimize the occurrences of that ever happening.
Yes.
All right. That's what the appeal process, all that stuff's for. Okay. We're not going to get too deep into that though. All right. So what would a type 2 error be in terms of a court case? Let's think about it this way first on type 2. Who won the case in the terms of type 2?
The guilty party.
Well, yeah, you get a little ahead here, but HO won the case, didn't they? Right?
Yeah.
We failed to reject, didn't we? Right? In type 1 error, right? H1 won the case because we rejected the null, didn't we?
Yes.
Okay. So in the case of type 2 error, what happened is we failed to reject the null when in fact it was false, okay? So what that did is we failed to convict a guilty person, right? Some people call this the OJ mistake. I saw that they've got a whole thing on OJ now on Netflix. So you failed to convict a guilty perp is one way of thinking about it, right? So their innocence was false. So in fact, they were guilty, but we failed to reject that. So we let a guilty person go is one way of thinking about it. We let a guilty person off the hook. Okay, so let's go take that back and let's go talk about that with respect to the divorcees now and see if we can do it from there, okay? Because what we're supposed to do over here, if we go take a look at our questions, they say, which hypothesis did it support? Could a type 1 or type 2 error have been made in the decision? Give the response in the language of the text. Also explain the possible error in context of the article. Okay, so help me out here, Katzen. Let's back up for a minute. Which of these two hypotheses, which of these hypotheses did the researchers end up supporting? Which one of these did they reject?
They found divorce to be guilty.
Okay, so what that meant is that they supported the alternate, didn't they, right?
Yes.
So they supported this, and then in red up here, we'll put that they rejected this, didn't they?
Yes.
Okay, so they rejected the alternate, and in its favor, they rejected the null. Let me say, because I think I said that wrong. Let me say it correctly. They rejected the null, and in its favor, you know, they're looking at the alternate as being what is probably the truth. Okay.
Yes.
All right. So based upon that, which type of error could have occurred in this study, type 1 or type 2?
Let's see. So they could have if they committed an error, it would have been a type 1?
You are doing awesome. Cooking with gas. Yes, that is it. Exactly. Okay. So the possible error, oops, let's go ahead and back to black here again. It doesn't say they made that error, but it's the only one they could have possibly made, right?
Right.
Okay. It's not saying they made a type 1 error. That's not what we're saying at all. What we're saying is that the possible error is a type 1 error.
Okay.
But it's like, again, we don't think we made that mistake, but if we did make a mistake, that would be the one, right?
Yeah.
Okay, so now I'm gonna leave it. I'm not gonna do this next part. You get to do this part on your own. Okay, I can't give it all to you. You got to tell me in context, just like we did here a minute ago with the cord analogy. What does that mean in context of the problem? What would a type 1 error be in context of the problem?
Let's see. In context of the problem, that
Yeah,
would...
let's not do it in the recording.
Oh, okay. Yeah.
You with me? I don't want to give that out to everybody. Okay. I think we've given everybody a lot as it is, so let's leave that off the recording, okay?
Right.
You tell me
right.
when I stop recording. You can tell me, and I'll give you a thumbs up or a thumbs down. All right, we'll wait until the recording stops. All right, so I think we're getting probably about there anyway because it's already after 9. So I think I've covered pretty much what Damien asked, and I love the questions Damien's given me because he's asking questions for everybody because I know that everybody's going to have my little bit of reading so far in the discussion. It seems to be all over the place, and so I think hopefully I'm going to post everybody say you need to go watch The Office Hour and see if that helps you with the discussion question.
Right.
Okay. All right. So let me. I'm going to stop sharing here, and I'm going to stop recording.